Hi everybody, Mr. Lee here. In this video, we are going to look at projectile motion, or the kinematics of objects that are launched horizontally. Now before we start, I want to go over a classic physics problem. This problem is about two objects, and in this simulation they're shown as a red ball and a blue ball. And the question is, if we drop the red ball at the same exact time that a blue ball is fired horizontally, okay, which one will hit the ground first? Now, you might have seen this problem before. There's a TV show called Mythbusters, and what Mythbusters said is, if you fire a bullet and at the exact same time you drop a bullet from the same height, which bullet will hit the ground first? The one that you fire or the one that you drop? Okay, so the same idea, except they used a bullet, and in this simulation we're going to use a ball. So here we have the red ball, which is going to be dropped, and we have the blue ball that's going to be fired. Okay, so make your predictions now. All right, ready? Let's do this. So we run the simulation, and we see that the two balls hit the floor at the exact same time. Isn't that cool? And the Mythbusters show, when they did this, they saw that the results were the same. The dropped bullet and the fired bullet hit the ground the same exact time. It was really, really cool. I'm going to include a link to this simulation so that you can play with it. But let's go into the physics behind this thought process. Alright, so now we're going to dive a little bit deeper into the classic physics problem of a dropped object and a horizontally launched object. So I have here on my screen a screenshot of the simulation. We have the red ball that has been dropped and the blue ball that has been launched. Now there's a couple of very important things. This red ball, it wasn't moving sideways at all. The blue ball, it was moving in the positive x direction. Now, you might be thinking to yourself, well, of course, like that's the whole purpose of a horizontally launched object. But that is actually very important, because the red ball has only, so I'll write this in red, the red ball has only, let's make this smaller, y variables, okay? Or only the y-axis is really making an impact here, compared to the blue ball, where the blue ball has both the x and the y variables working for it. All right? So what that means for us is that the y-axis here is the same as the y-axis motion for this blue ball. And we can see that because as the blue ball is moving forward, it's also dropping. And we can actually match it up because this is showing us a motion diagram for the red ball and the blue ball. And we can see that the red ball falls at the same rate as the blue ball. Okay. The only difference here is that the blue ball is being shot forwards. So this is moving forwards and dropping, whereas the red ball is just dropping. And the thing that ties the two motions together is that both are experiencing the same acceleration. And we know that the object is accelerating because the difference in positions, we can see that it increases as it falls down. As time moves on, the object is moving further and further away. So we can say that the object is, well, it's speeding up. And anytime an object speeds up, slows down, or changes direction, we can say the object is experiencing an acceleration. And in this case, both objects are experiencing an acceleration in the y-axis. Okay? And that is the acceleration due to gravity, which is negative 9.8 meters per second squared. All right. The only difference, once again, I'm pointing out the obvious, the only difference is that the blue object also has x variables working for it. Okay, it's also moving forward. Now, we can see here that when the object is moving forward, believe it or not, the spacing in between each of these pictures is the same. We can see here that it is at this crosshair. The object here is once again at this crosshair, so it's moving one block per snapshot. Here, if I were to move this object up, it will be here at this crosshair. Here, if I were to move this object up, it will be at this crosshair. This object is here at this crosshair. This object is up here at this crosshair, and this object is up here at this crosshair. So what we can say here is that for the blue ball, the X motion is constant. All right, so here we have a very important phrase, constant motion. Okay, if we have an object with constant motion, what is your acceleration? What is your acceleration in your x-axis? Okay, so this idea of constant motion means that your velocity is constant. And if you have constant velocity, remember, when you have constant velocity, your acceleration is 0. Because acceleration tells us that an object is speeding up or slowing down, but if your velocity, your motion, is constant, it's doing neither of that. Okay, so we can see how even though the x-axis is constant, or the x motion is constant, because this object is experiencing y acceleration, it gives us this effect of a object that is being launched horizontally. So the x motion is constant, but the y motion is accelerating. Okay, it's speeding up in the y direction. And if we were to describe the velocity of the object, we would say here at this point, the object has only a x velocity, because remember, the y velocity at the peak is always going to be 0. But then as the object is being fired forward, both the y and the x-axis, okay, or the motions, they affect the ball. So we can say here that the motion of the ball is going to be like this. Okay, as the ball moves forward and forward, the velocity in the y direction it increases, because remember, the velocity changes in the y-axis because it's experiencing velocity. Okay, so you'll notice that I'm drawing my arrows longer and longer, and that's just to show us that the velocity in the y-axis is increasing compared to the velocity in the x-axis. I'm going to make that the same. Okay, the velocity in the x-axis is constant. That doesn't change. So how does this affect the velocity overall? Well, in the beginning, because there was no y velocity, the x velocity becomes the overall velocity. But after the next moment in time, it has both the x and the y, and so we have this vector right there that shows us that the x and the y is affecting it. And as time progresses, we see that the y velocity is affecting it more and more, like so. Okay, and then these should all be straight lines, and eventually we know that the object is moving in this direction, and the velocity is pointing in the direction of the motion at that moment. All right? Okay. So that is the breakdown of the horizontally launched projectile. In the next video, I'm going to go into the math behind the horizontally launched projectile. So I will see you then. Bye-bye.